Lesson 1-10 pulls together all previous Topic 1 lessons. Your task, as written at the top under the key concept, is to make sense of real world situations and decide the appropriate operation or operations to use. Let's get started. Today's essential question reads, how do you decide which rational number operations to use to solve problems? Go ahead and write down this information. You need to make sense of the problem and understand how the two quantities are related in order to determine which operations to use to solve it. You're going to look for clues in the word problem, specifically the wording of the problem, keywords that indicate the operations that you need to use. Additionally, if your units of measure agree, like dollars and dollars, you can only add or subtract. When your units of measure are different, like the number of days and the amount spent, so you have days and you have dollars, you can't add and subtract things that are not the same. So that would indicate that we would use either multiplication. So those are other things to consider, and we will touch upon all of that as we go through our do you know how questions. Okay, question number 2, the reasoning. A truck's position relative to a car's position is negative 60 feet. Cars move in the same direction, but the car moves 5 feet per second faster for 8 seconds. What operations could be used to find the truck's relative position after 8 seconds? Explain. So in this problem, we're not really solving for the position, although we'll mention it. It's really just a discussion on knowing which operations to choose from and to apply. So go ahead and write down this information, think about it, and then circle the correct word that is on the line. Okay, at the top, we're going to start by multiplying to find the number of feet the position of the truck changes relative to the car in 8 seconds. We're comparing the number of feet and the number of seconds, so we can only multiply or divide. Okay, so that right there narrows our operations down to 2. We are going to multiply since we know that the car is ahead 5 feet every second for 8 seconds. Now our focus is on the truck's position. So if the car continues to move forward 5 feet, the truck's position is going to continue to fall behind. So we would actually have a -5 times the 8 to get a -40. Next, we are going to add that negative number, which I said was a -40, to to that -60 feet, which was the original position when the problem started. So again, since we get -40 when we multiply the -5 and the 8, we're now in feet, -40 feet. And we have this number here, the -60 feet. Since the units of measure agree, we will be working with addition or subtraction. So it does help to narrow down our choices of operations. And then we just need to decide if we are adding or subtracting those numbers. So again, really nothing that we were solving there, although if you have that -40 and then we're adding that to the -60, the truck's position would be behind the car by 100 feet, which would be -100. We really just wanted to focus on, the steps and understanding the process. Okay, number 3, construct arguments. It says that Emilio used addition of 2 rational numbers to solve a problem. Jim used subtraction to solve the same problem. Is it possible that they both solved the problem correctly? So again, one's using addition, the other is using subtraction. Is it possible for them to arrive at the same value? So this is just sort of a yes or a no response. Think about it and circle the appropriate answer. So it's always a good idea if they give you a statement like this and there's no numbers involved, that you use your own numbers and try to see if you can work it out. So I said right here, and you're going to write that down, that Emilio could have used 3 plus -5. So that is an addition problem. And that would result in a -2. Jim could have used a subtraction problem and writes 3 minus 5. Well, that's also -2. Because when you have subtraction, you're going to actually do the additive inverse. So this problem would really be the same as Emilio's, 3 plus a -5. But his operation that he started with was a minus. So the expressions that they used are different. They have different operations, but they have the same value. So the correct answer is yes. Okay, if we go to the practice problems under the Do You Know How, we'll start to think about whether our units of measure agree, because that can give us a lot of information with the operation that we need to use, but also looking for other keywords that indicate the operations as well. Okay, so with number 4, says that Kara had a savings account balance of $153. That was on Monday. And then the next day, Tuesday, she had 6 withdrawals of $15.72 plus a deposit of $235.15. What was her account balance after all of these transactions? So let's just organize our space first of all. We have what's happening on Monday, and we have what's happening on Tuesday. And then we're going to end with the balance. That would be like our final calculation. So on Monday, there's this balance. She looked, maybe one sees that she has $150. That would be positive because it's much she has in the bank. On Tuesday, we have 6 withdrawals, okay, and the amount is $15 each time. Okay? So we're comparing the number of withdrawals, the dollar amounts. Since those are different units of measure, number of time and dollars as multiplication. So we're going to take X. Withdrawal. Think about what a withdrawal is. You heard here that is taking out about it's in withdrawal. So since it is taking money away in the account, we're going to use 50, 70. Okay, and again, our units of measure did not match up, so this is either we're going to multiply or divide, and it's the number of times. But then she also makes a deposit on Tuesday, $235.15. Okay, now to figure out what's going on Tuesday, we're going to use order of operations. We're going to start by multiplying the 6 and that negative $15.72. Go ahead and do that, and you're going to write your answer right below. Okay, if you have 6 withdrawals of $15.72, you have a total withdrawal of $94.32 that day. Now that's how much you're taking out of the bank and spending, but then you're going to deposit $235.15. Now notice I'm adding here, and that's going to work because my units of measure match up. These are both dollar amounts, so I can add and subtract dollar amounts. So go ahead and add those two numbers together. Just keep in mind that that first number is a negative $94.32. Put your answer right below. Since the two numbers have opposite signs, I'm actually going to subtract those amounts, and the difference between their absolute values is $140.83. Since the positive number is larger than the withdrawal, the negative number, I'm going to end up with a positive number for that day. So on Monday, I start with $153. On Tuesday, it looks like I'm going to add $140.83 to Monday's amount. And again, since I'm working in dollars for both numbers, I would only add or subtract since they are both positive. I would add them together and the balance would remain positive. That would give me a total of $293.83. Okay, moving to question number 5, we have a scuba diver. He's swimming at a depth, the depth shown. So he's below sea level. Here's sea level. Sea level is 0 feet. Anything below sea level would be negative, so we have his position at negative 46 feet. He is going to swim toward the surface, so this is going to be a key word. And if you're moving toward or you're going up toward the surface, that would be a positive number, right, or addition. And it's going to happen every 3 seconds for a total of 15 seconds. Okay, so let's try to put this all together. Negative 46 feet is the starting position, so that would be our starting number. Now, since we're going to go up or toward the surface, that's indicating addition. When you move up toward the surface, we're going to add a positive number. So we would be adding a positive half a foot. And that would be every 3 seconds, but for a total of 15 seconds. So how many times is he going to move up, right? So if he starts here and he goes up 3 seconds, and another 3, and another 3. So now I'm at 3 threes, which would be 9 seconds. Another 3 seconds, he's at 12 seconds, and then 15 seconds goes by. Now, each time we have one of those changes in position, we're adding the 0.5 feet. Oops, need my pluses. Okay, so we have this 0.5, that was 3 seconds, another 0.5 was 3 seconds, so on and so forth. So I'm taking my half a foot and I'm multiplying it by 5 times because 5 times is that 15 seconds. So what is the new position? Well, again, we're going to use the order of operations. So we're going to go ahead and multiply our feet and our seconds. Again, they're different units of measure, feet and seconds, so we can only multiply or divide them. And then that would result in a positive 2.5 feet. We'll bring down that 46 and the addition symbol. And now we have 46 feet and we have 2.5 feet. Again, the unit of measure is the same, feet and feet, so we can add and subtract them. So if you could right now add negative 46 and 2.5 and give me his new position. The scuba diver's new position would be negative 43.5. I had different signs here, so when you add with different signs, you're actually subtracting to get that 43.5. And since the negative number was the larger absolute value, my final answer will be negative. And he'd still be below sea level, so that should definitely be negative. Finally, number 6. The temperature of a cup of coffee changed by negative 54 degrees over 22.5 minutes. What was the change in temperature each minute? So the first thing I want you to do here is circle for me the units of measure. In the word problem, circle the words or symbols that show the units of measure. So I'm measuring the temperature in degrees Fahrenheit, and I'm measuring the amount of time in minutes. Those are different units of measure. It's not like I'm comparing degrees Fahrenheit with degrees Fahrenheit or minutes to other minutes. I'm in different units of measure for my two numbers. So this is a multiplication or division problem, okay? So what we want to do here is write a rate that compares these two. So we're going to use the negative 54 degrees Fahrenheit, and we're going to put that over the number of minutes. And rates are division problems. So I set up my fraction as a rate, and this becomes a division problem. The other thing that gives away that this is going to be a division problem is that I'm starting at this 22.5 minutes, and I want to not increase the minutes, I want to go down to just a single minute. So if you're looking at multiplication or division, this would be division since the number is getting smaller. Okay, so this is what we call a stacked fraction. You're going to convert any mixed numbers to improper fractions. And then you want to just write your problem horizontally instead of having it stacked. Okay, so we're going to convert the negative 54 to negative 54 over 1. We're going to make an improper fraction only because we're going to divide fractions here. So we want both of our numbers to be in fraction form. Using the circle method, starting at the bottom and working our way around, we're going to take this 2, which is our denominator. We're going to multiply it by the whole number to get 44. We're going to add that number on the top to get 45. Now our improper fraction will have the same denominator as our mixed number because that's telling us what we're working with. We're working in halves. Now, if we had a calculator, we could just put those numbers and we could hit the divisions, the divide key on a calculator. The calculator would do all the work. However, as you know, the PSSAs and just, understanding the whole process here, because the calculator only helps you if you understand how you're plugging all of those numbers and operations in. You cannot divide on paper two fractions, but we can multiply fractions. So what we want to do is change our division problem to a multiplication problem using the multiplicative inverse. And the 3 steps to do that: keep, change, and flip. We just write those letters above: K for keep, C for change, F for flip. Right below, I will rewrite this as a multiplication problem. So we're going to keep that negative 54 over 1. We'll change division to multiplication, and we will write the reciprocal, which is the flipped version of that 45 over 2. So that would become 2 over 45. Now that you have an x between, so we're in multiplication, you kind of can see if you extend the lines, like we have those diagonals, right? We're going to go ahead and cross simplify. 54 and 45 can both be divided by a 9, and that is the largest number that both numbers can be divided by. So we're going to go ahead and factor that number out, which is dividing the number out. Negative 54 divided by 9 is negative 6. So we'll change that to negative 54 to a negative 6. And positive 45 divided by 9 is a positive 5. Now we're ready to multiply across our numerators. We have a negative 6 times a 2. We get a negative 12. 1 times 5 is 5. So our final answer is negative 12 fifths. And we would want to change that to a mixed number. Here's a little visual for you as we do the long division. Now I'm going to leave off that negative just so it doesn't get confusing with all those extra symbols. And we'll divide the 5 into the 12. It goes in twice. We get a remainder of 2. We have nothing else to bring down. So now I'm going to complete that circle for the circle method. Starting at the top, we have our whole number. Working our way around, the remainder here becomes our numerator, and the 5 is our denominator. So final answer would be -2 and 2/5. And that would be the change in temperature would be degrees Fahrenheit. We want to go ahead and maybe include that unit of measure in the final answer. Okay, this ends the information for section 1-10. I hope you all have a good